Good morning, everyone. So it's a great pleasure to be here, and thanks for the opportunity to come to share some of our research work about the role of honeybee virus in honeybee colony losses with each of you in audience. Thanks Kevin, Jim, and Charlie for the invitation and the arrangement. Let me begin my talk by giving you a brief roadmap of my talk. So I want to start my talk with a brief overview of a honeybee health problem facing beekeeping industry today. Then I will move on to the topic, the possible role of honeybee viruses, particularly Israeli acute paralysis virus in honeybee colony losses. Then I will also covering some of our research effort in investigating epidemiology, transmission, pathogenesis of virus, and virus-host interaction in honeybee. So the reason I want to focus on honeybee viruses is many years ago, I forgot exactly year, I joined the New Jersey Beekeeper Association meeting and shared the virus story with the group. So over the year, we have improved our understanding about the role of viruses in honeybee colony losses. That's why today I want to focus on viruses. Actually, over the year, my research team, we also have evolved the research work of another important pathogen, Leucemia, the role of Leucemia in honeybee colony losses. So in the future, I hope I will have an opportunity to come back to share Leucemia story with you. So finally, I will also sharing some evidence of therapeutic potential of RNA interference in controlling virus replication in honeybee with you. Honeybee colony losses has been a continuous and growing challenge for research and beekeeper. According to an annual nationwide survey conducted by BIP, Bee-Informed Partnership, and the USDA showed that the annual overwinter losses rate have been averaging around 31% since 2006, which is significantly higher than 15% loss rate, which is considered economically sustainable. In addition, beekeepers not only lost bee in the winter, but also throughout the summer. According to a latest nationwide survey, showed that the annual bee losses for 2014 to 2015 was 42%, with summer losses exceed winter number for the first time, posing a new challenge for beekeeping industry. So unfortunately, the decline of honeybee health and honeybee population has come concurrently with increased need for honeybee pollination service. In the US, the decline of managed honeybee colony has declined steadily over past 60 years, especially after the introduction of parasitic mite, Varroa destructor, back to 1980s. The number of honeybee colony has dropped from the 6 million in 1947 to 4 million in 1970 and 3 million in 1990 to less than 2 million in 2013. The decline are especially alarming considering occurrence of honeybee colony collapse disorder, CCD, during the winter of 2006 to 2007. So when over 600,000 honeybee colony mysteriously disappeared, beekeepers in 23 states report a problem. Some commercial beekeepers lost over 80% of their honeybee colony. The crisis of honeybee caused by CCD represents one of the most significant threats for the U.S. beekeeping industry. The causes of CCD, the pathogen and the parasite, traditional pathogen and the parasite, including Varroa Mite, trichal mite, American foulbrood, European foulbrood, chalkbrood, were excluded as a potential cause of CCD because they don't have a history of promoting CCD-like disease symptom. Several factors, including new emerging pathogen and parasite, pesticide residue, poor nutrition, environmental factor, like the cold temperature, and beekeeping practices such as migratory stress have been proposed as a potential cause of CCD. Some speculative factors such as cell phone radiation, genetically modified crop with pest control characteristics such as Bt toxin were also proposed as a potential cause of CCD. An experiment was conducted using gamma irradiation, treated the beehive in which bee live, showed that the cause of CCD could be knocked down by gamma irradiation, pointing toward a parasite or pathogen as a leading cause of CCD. A study by consulting scientists using metagenomic approach screened the microflora of CCD-affected colony and normal health colony. One striking result from this study was the observation of tight correlation of between CCD and a virus is really acute paralysis virus, IAPV. IAPV was detected in over 80% of CCD-affected colony, but in less than 5% normal strand colony. The origin of IAPV is not clear. IAPV was first reported in Israel in 2004, where infected bee was presented with shivering, progress to paralysis, and just died outside of beehive. IAPV was not recognized in the US prior to CCD outbreak. The science paper also reported that IAPV was detected in Australia package bee, which led us to the first question: was IAPV introduced to the US while Australia package bee? As CCD first appeared in 2004, the same year when US started import bee from Australia. Also, IAPV had previously detected in Australia. In order to provide the science-based information for US safe trade decision, we conduct a study to investigate the historical presence of IAPV in US bee population. Bee sample collected in Maryland, Pennsylvania, and California during 2002 to 2007 were examined for presence of IAPV. Those pictures were taken at David Hagenberg's apiary. David was the first US beekeeper to report CCD. The result showed that IAPV was detected in B sample collector prior to 2004, suggests that IAPV has circulated in USB population for some time, even before we started import bee from Australia. Further genetic analysis showed that US strain IAPV clustered together distantly related from Australia strain of IAPV and China and the Israeli strain of IAPV downplay the importance of importation of packaged bee from Australia for appearance of CCD. While IAPV was found to be better correlated with CCD than other pathogens we examined, the result that 25 out of 30 CCD affected bee tested positive for IAPV did not fulfill Cox postulate. The golden standard for establishing causing relationship between pathogen and the disease. The first criteria of Cox postulate is the pathogen must present in every diseased individual. So our research did not fulfill this criteria. So then, which lead us to the next question. Was IAPV a significant marker for CCD or a causal agent of CCD alone in concert with other factors? A study was conducted to examine bee sample collected in 2006 prior to widespread of CCD, and in 2007 from CCD-affected colony and normal strain colony. The results showed that IAPV, along with other pathogens, were more prevalent in CCD-affected colony comparing to normal strain colonies. Along with the high titer of viruses and other pathogens, CCD-affected colonies showed a strong correlation between different pathogens. The thickness of the line indicated the level of positive correlation between different pathogens, as you can see from the slide. Weak colony had a significantly strong positive correlation between different pathogens comparing to strong colonies. We conducted a 10-year field survey to investigate seasonal activity of viruses in field colony. The results showed, so the field colony were divided as a strong and weak colony based on the size of adult bee population, amount of sealed brood, and the presence of food store. The results showed that IAPV was the third most common virus infection in honeybee colony after deforming virus and the black queen cell virus. The prevalence of IAPV along with deforming virus and black queen cell virus were significantly higher in the weak colony comparing to strong colony. As with the deforming virus and the black queen cell virus, IAPV showed a strong seasonality. The infection rate of virus increased from spring to summer and fall, peaked in winter, while colony classified as a strong colony all survived through cold winter. All the weak colony perished before February. Based on our research finding, we conclude that the virus infection, I need to walk closer to the screen. This morning I realized I forgot to bring my eyeglasses so I can read. So virus infection could have a significant negative impact on colony survival. Okay, great. And the presence of virus in bee colony has a high predictive value for colony declines. IAPV was not only culprit responsible for colony decline. Colony losses may be caused by interaction of multiple agents in combination. IAPV is a significant marker for CCD, but how does IAPV spread in honeybee colony? Transmission of a virus is important for a pathogen persist and spread in host. Knowledge of how a virus is transmitted is fundamental to the design of appropriate disease control strategy. In nature, a virus can be transmitted horizontally or vertically or both. In horizontal transmission, viruses are transmitted among individuals of the same generation. In vertical transmission, viruses are passed vertically from mother to offspring through eggs. Our study of virus infection in honeybee colony showed that IAPV could attack the different stage and cast of honeybee, including egg, larvae, pupae, adult worker, drone, and queen. In addition, IAPV was detected in colony food, including honey, pollen, and royal jelly, suggesting a foodborne transmission of IAPV in honeybee colonies. Localization of viruses in egg and the queen tissue showed that IAPV was detected in spermatheca, a sac in queen's body for storing semen, suggesting venereal transmission pathway of IAPV in honeybee colony. Venereal transmission happens during the between two sexes during the mating. Detection of IAPV in egg and the queen ovary suggesting vertical transmission of the IAPV from infected mother queen to the offspring. Varroa Mite has been catastrophic for beekeeping industry, for U.S. beekeeping industry, since it is first detection in 1987 in Florida and Wisconsin. Currently, the scientific consensus is of all the identified factors that negatively impact pollinator health, Varroa Mite is the most determined pest of honeybee. Several studies demonstrated experimentally Varroa Mites not only cause direct damage to honeybee during blood feeding, they also create entry for viruses by acquiring viruses from diseased individual and transmit the viruses to healthy individual. The study also showed that Varroa mites causing serious demise of honeybee by suppressing honeybee immunity and boost virus amplification. The virus and the Varroa Association has contributed to the deaths of millions of bee colonies worldwide in past decade. we conducted a study to investigate the likelihood and ability of Varroa mites in transmitting IAPV among honeybee. The honeybee from strong and weak colony were further divided into different subgroups based on the level of Varroa mites introduced. The result showed that while the subgroup of honeybee did not expose to Varroa mites test negative for IAPV, there was a positive correlation between number of honeybee became IAPV positive and the percentage of Varroa mites introduced to the colony. The title of IAPV in infected bee was also positively correlated with density of Varroa mites introduced and the time and period of Varroa mites feeding. The higher density of Varroa mites introduced, the longer period of Varroa mites feeding, the higher copy number of IAPV was detected in the infected bee. However, the magnitude of IAPV copy number in response to variable Varroa mites challenge was less significant in strong colony comparing to the weak colonies. Our result clearly showed that IAPV infection in honeybee colony involved multiple transmission pathways, including foodborne transmission, venereal transmission, vector-borne transmission, and the mother to offspring transmission. Both horizontal and vertical transmission are important survival strategy for the virus. When honeybee colony are under health condition, the virus maintained in the colony as a latent infection without causing any acute sign of disease. Alternatively, when honeybee colony are under stress conditions such as overwinter stress and poor nutrition, the virus tended to leave its latent state, started to replicate, become much more infectious, lead to death of honeybee and the possible collapse of entire bee colony. Such a flexibility of virus transmission may explain the high prevalence of IAPV in honeybee colony. The next few slides may be too technical, so I'm going to skip a few slides. But I wanted to share one result with you is we conducted a study to investigate the host response to IAPV infection. Our result showed that IAPV induced significant profound host immune response in adult bee, then in brood stage. So the transition of latency in brood state to the activation in adult stage may be triggered by exogenous factor or stress that affect the adult stage. Our study of virus epidemiology, transmission, pathogenesis, host and pathogen interaction, the ultimate goal of our study is to use knowledge of genetic basis of host susceptibility and the pathogen virulence, use the knowledge to identify novel target for development of antiviral strategy. RNA interference is a natural process that cells used to knock down the activity of a specific gene, has emerged as a potent therapeutic strategy for controlling pathogen and the parasite. IAPV genome contain two critical genetic elements. Biologic, acquired by Monsanto a few years ago, developed a product, RIMA-B, you probably haven't heard about it. So RIMA-B, by targeting one critical genetic element, the feeding and the injection, the feeding and the injection of RIMA-B showed significant reduction of abundance of IAPV under both field and laboratory condition. We conducted a study to further explore the antiviral potential of RNAi in controlling IAPV infection in honeybee by targeting another critical genetic elements. Our study showed that the IAPV infection rate in the group received IAPV RNAi treatment was significantly lower than group without RNAi treatment and exposed to the Varroa Mite challenge. The result also showed that the IAPV copy number in the group received RNAi treatment was significantly lower than group without RNAi treatment and exposed to Varroa Mite challenge. Our result confirmed that RNAi holds great therapeutic potential for combating viral diseases in honeybee. Over the year, we have significantly improved our understanding of virus transmission, epidemiology, pathogenesis, host pathogen interaction. We also showed that IAPV is a significant marker for colony losses and has a significantly negative impact on honeybee survival. However, exact cause of honeybee losses, including CCD, are still unknown. Based on all the research funding accumulated so far, currently the scientific consensus is while there is no single factor has emerged as a definite cause of CCD or colony losses, multiple factors, including new parasite pathogen, pesticide residue, environmental stress, including global warming, disruption of forage area due to urbanization, that work together may compromise honeybee immunity and disrupt their social system, lead honeybee more susceptible to the disease, and lead to honeybee colony collapse. Well, as we are committed to searching, implementing solutions to improve pollinator health, our continuous effort include, I need to move to the, include, it's on, okay, conduct a survey and did I turn off? Okay. That's okay, that's okay, that's okay. So we will continue to conduct a survey and collect the data on bee health, and analyze bee sample for pest, pathogen, disease, and conduct a controlled experiment to identify the role of individual factor on colony losses. Then we will develop effective control strategy and the management practice guideline to reduce susceptibility to colony disorder and to improve bee health. As you can imagine, that's okay. Okay. As you can imagine, no project could be accomplished with a lot of people's effort. This is the B lab research crew I'm representing. The postdoc, visiting scientists, graduate students, I'm not going to name them individually, work in my lab, contribute significantly to the research result I just presented. Thank you for your attention. I will be happy to answer your question. Yes.
Wait 1 second for Jen.
Oh, maybe now I can move.
Yeah.
Okay, great.
What has happened with Remedy since it's been acquired by Monsanto? Does it hold any promise of being, very efficacious?